Deepan, unmute your mic. The introduction on pharmaceutical analysis and chromatographic analysis. He asked Deepan, are you there? Monisha, Padmapriya,
Yes, ma'am.
Monisha,
Yes, ma'am.
say about the topics what we have discussed.
Rules on theory classes and rules and regulations on practical cases. Then, what is pharmaceutical analysis? Pharmaceutical.
ஒரு செகண்ட் இங்க இன்ஸ்ட்ருமெண்ட் சர்வீஸ்க்கு வந்திருக்காங்க.
Okay, ma'am.
I will see through it. Continue, Monisha.
Yes, ma'am. Pharmaceutical means to identify purity, quantity, quality. It has two types: quality control and quality assurance. Quality control means product oriented. It has two types: qualitative analysis and quantitative analysis. Next, quality assurance is a to ensure the safety and efficacy. Then overall view on syllabus, separation techniques, spectroscopic analysis, chemical methods of analysis, quality assurance. On overview of separation techniques, we have three types: planar chromatographic analysis, columnar chromatographic analysis, and miscellaneous chromatographic analysis. In planar chromatographic analysis, paper paper analysis, TLC and HPTLC, thin layer chromatographic, high performance thin layer chromatography, columnar chromatographic analysis, column adsorption, high performance liquid chromatography, ion exchange, liquid chromatography. In miscellaneous chromatographic analysis, phoresis, gel filtration, and affinity chromatography.
Okay, pa. Anybody else? Monisha, thank
Thank
you.
you.
Anybody else is interested to present? Rubishwaran. Can you explain the same what Monisha has explained? Can you summarize the topics what we have discussed in the last class? Rubishwaran. See, if you are not responding, then your attendance will be automatically absent. You can respond even if you are not understanding, you can tell and you can clarify the topic. Stephen. Vimal.
Hello. Hello.
Yeah, tell.
Ma'am, the chromatography techniques used in pharmaceutical analysis, ma'am. There are several types. Planar chromatographic analysis, ma'am. In this, they are using paper, thin layer chromatography, and high performance thin layer chromatography, ma'am. These are all plain mediums. And next is column chromatography, ma'am. In that, they are using column adsorption, high performance liquid chromatography, and ion exchange, gaseous liquid chromatography, ma'am. And next is miscellaneous chromatography, ma'am. In this, they are using electrophoresis and gel filtration.
One more is affinity chromatography.
It is also in miscellaneous chromatography.
Okay, good. Stephen and Monisha, thank you. So we'll start with the next introduction on spectroscopic analysis. It is the second part of pharmaceutical analysis. Quality control methods. Among quality control methods, the second category of analysis. So there is overview on spectroscopic analysis. Can you see the slides now?
Yes, ma'am.
Okay. First, we'll be dividing this spectroscopic analysis. It's like chromatographic analysis, how we have divided into planar and columnar chromatography. Likewise, spectroscopic analysis also divided into several categories according to its application. Okay. So first portion is electronic spectroscopy. And the second category is structural elucidation spectroscopy. And third is miscellaneous types. In that, miscellaneous spectroscopic methods. First, let's see about electronic spectroscopy. Why we are calling some group of spectroscopic analysis as electronic spectroscopy means the detection or characterization of molecule occurs at electronic level, electron level. Okay, like valence electron level in the molecule or in the atom, it occurs at electron level. Okay, so it is called as electronic spectroscopy. By means of radiation, when we use radiation for analysis at electronic level in the molecule, then the spectroscopy is called as electronic spectroscopy. Already I told spectroscopy means we'll be using electromagnetic radiation for the analysis of analyte. So analyte at analyte, the radiation will react on its electrons. Okay, mainly valence electrons. So it is called as electronic spectroscopy. Below, whatever spectroscopic analysis is given is based on electronic spectroscopic analysis. In that, there are two types, absorption type and emission type. What is absorption? So here the radiation, electromagnetic radiation is absorbed by the sample, that is analyte, what you are going to analyze. The sample, either drug substance or drug product, will be absorbing the radiation for its analysis. What is emission? The same. The molecule, whatever radiation is absorbed by the molecule will be emitted, where emitted light, emitted means it is coming out from the sample as radiation. That radiation is analyzed by the amount for both qualitative and quantitative analysis is carried on the emitted light from the molecule or atom. So it is called emission spectroscopy. In under absorption spectroscopy, there are two categories, UV visible and atomic absorption. UV visible and atomic absorption. This absorption again divided into molecular level spectroscopy and atomic level spectroscopy. Under molecular level, it is known as UV visible spectroscopy. So molecules will absorb UV or visible radiation at molecular level. If you take a whole molecule will absorb the radiation. So that absorbed radiation is analyzed qualitatively and quantitatively for knowing the purity of the sample. That is called as UV visible spectroscopy. And what is atomic absorption means? The absorption occurs at atomic level. But the single atom, mostly heavy metals, will absorb heavy metals and alkali metals will absorb the radiation at atomic level. So under absorption spectroscopy itself, there are two types, molecular level and atomic level spectroscopy. For example of molecular level spectroscopy is UV visible, atomic level spectroscopy is atomic absorption. Coming to emission under electronic spectroscopy, fluorimetry and flame emission. Fluorimetry occurs at fluorescence. Emission of fluorescence occurs at molecular level, where flame emission. Flame is what?
Ma'am, Rafiq class join பண்றாங்க ma'am. நீங்க request accept பண்ணுங்க.
வேற யாரோ ஜாயின் பண்றீங்களா? ஓகே, அவ்வளவுதானப்பா. 17 மெம்பர்ஸ் இருக்கீங்க. தீபன் ஹாஸ் லெஃப்ட் தி மீட்டிங் வருது. பட் இடையில ஜாயின் பண்ணனும்னா அப்புறம் கிளாஸ் இன்டரப்ட் ஆகும் இல்லையா?
ஆட்டோ ஜாயின் இருக்குங்க, அது போட்டு
ஆட்டோ ஜாயின் கொடுத்தாலும் அது அப்படிதான் வருது. நான் அந்த ஆட்டோ ஜாயின்ல கொடுத்துருக்கேன். ஆக்சுவலா அந்த பேஜ் ஓபன் பண்ணாதான் நீங்க ஜாயின் ஆக முடியுது. ஏன்னா இது ரெக்கார்ட் ஆகிறனாட்டி மீட்டிங் அந்த மாதிரி தான் இருக்குப்பா ஆப்ஷன். சரியா? டொமைன் மெயில் ஐடியில இருந்து ஓபன் பண்ணும்போது நான் அந்த பேஜ் ஓபன் பண்ணாதான் ஆட்டோமேட்டிக்கா வருது. பட் அந்த பேஜ்ல நான் இருக்கணும். மீட் பேஜ் ஓபன் பண்ணா ஆட்டோமேட்டிக்கா அட்மிட் ஆயிருது. ஓகேப்பா. வேற மெயில் ஐடியில இருந்து ஓபன் பண்ணோம்னா அதுவே அட்மிட் ஆயிக்கும். ப்ராப்ளம் இல்லை. Okay, so under spectroscopy, first category is electronic spectroscopy. In electronic spectroscopy, there are two types, absorption and emission. It is based on the absorption of radiation and emission of radiation as measuring this type of electromagnetic radiation. So absorption spectroscopy and emission spectroscopy. So when we study briefly about individual spectroscopic analysis, you will be knowing the concept, how the radiation is absorbed or emitted. What is the each and every mechanism, whatever exists behind the spectroscopic analysis, we will learn under individual topic. Okay, now you have to know only the structure of spectroscopic analysis. Under absorption and emission, there are two types, molecular level absorption and atomic level absorption. Molecular level emission and atomic level emission. For molecular level, example is absorption is UV visible. Atomic level, it is atomic absorption spectroscopy. You can find the picture of the spectrophotometer used for that purpose. Okay, and here fluorimetry, fluorescence emission at molecular level. Here flame emission, using flame the radiation will be emitted from the molecule, so it is called flame emission. It is occurring at atomic level. These two techniques are more or less relevant to each other. Likewise, UV visible and fluorimetry are both are similar to each other. Only absorption and emission will be varying. Okay, so molecular level absorption is UV visible, molecular level emission is fluorimetry, atomic level absorption is atomic absorption spectroscopy, atomic level emission is flame emission spectroscopy. Let's move on to structural elevation spectroscopy. There are 5 categories of structural elucidation spectroscopy. Why it is known as structural elucidation means by analyzing your analyte or any chemical molecule by means of these spectroscopic methods, you can predict the chemical structure or you can confirm the existing structure of a molecule. Okay, so that it is known as structural elucidation spectroscopy. Chemical structure means what are the information you will get, what type of bond and what type of functional group a molecule has, at what position the functional group is attached, whether it is aliphatic or aromatic, alcoholic or amide, type of molecule information we'll be getting through analyzing your compound by means of all the spectrophotometric analysis. Okay, in that first technique is infrared spectroscopy. Under structural elucidation, preliminary technique is infrared spectroscopy, from which we can analyze functional group of the molecule, what functional group it has. Then nuclear magnetic resonance spectroscopy, NMR, by means of which we can find what type of hydrogen, proton and carbon is existed in the molecule. Organs can be analyzed by using NMR analysis. Okay, organic molecules can be analyzed. Organic means definitely be having carbon and hydrogen. So what type of carbon is existing in the molecule, what type of proton is existing, where it is existing in the molecule, whether it is existing as CH2 group or aromatic group CH in aromatic. Likewise, complete information will be getting by NMR. So this is next step of IR spectroscopic analysis. So after IR, you need to perform NMR spectroscopic analysis. Then electron spin resonance spectroscopy, it is mainly applicable for analyzing free radical compounds. Okay, electron spin resonance, it is not the most important spectroscopy among structural elucidation. After IR and NMR, we will be moving on to mass spectrometry. But according to your syllabus, ES are also important to analyze. It will be applicable to analyze free radicals. Free radicals mean it will be having odd electron in the molecule, whichever molecule is having free radicals, odd electrons, not unpaired electrons. So those type of molecules will be analyzed by electron spin resonance spectroscopy. Then mass spectrometry, by means of which we can analyze the molecular mass of the compound. If you take a chemical molecule, you will be saying it has 100 gram per mole. So that amount, molecular mass can be, molecular weight can be determined by mass spectrometry. So after IR, NMR analysis, we will be moving on to analyze the detected molecules, molecular weight here. Then X-ray diffraction spectroscopy. This will say the molecule, whether it is a crystal or amorphous, what nature it is. Okay, that type of analysis can be carried out by X-ray diffraction analysis. So these are all the structural elucidation spectroscopy from which we can get information about a complete molecule, or you can predict unknown molecule chemical structure, or you can confirm whether the existing molecule is having particular functional group, expected functional group, basic nucleus, everything will be confirmed here, so that it will be directly indicating the therapeutic effect also. If a particular functional group and basic nucleus is there only, we can expect the expected therapeutic activity. It will be formed by using this technique, structural elucidation spectroscopic methods. So what are the structural elucidation spectroscopic methods? Infrared, nuclear magnetic resonance, electron spin resonance, mass spectrometry, and X-ray diffraction. 5 techniques: IR, NMR, ESR, mass spectrometry, and XRD. This is a short form of these techniques: IR, NMR, ESR, mass spectrometry, and XRD. Okay. So what are the classification we have seen under spectroscopy? Electronic and structural elucidation. We can even divide the spectroscopy into many types according to its applications, but it is the common classification for spectroscopic methods, electronic and structural elucidation. According to your syllabus, it is classified. So we will be moving accordingly what we have decided here. So similarly, we'll be moving into the syllabus, and we'll be learning each and every parameters aspects under each spectroscopic methods. Okay, under electronic, absorption and emission; under absorption, UV visible and atomic absorption; under emission, polarimetry and flame emission; under structural elucidation, IR, NMR, ESR, mass spectrometry, and XRD. And next we'll see about miscellaneous spectroscopic methods. Apart from it, what are the techniques? Polarimetry and thermal analysis. Polarimetry means we can check the optical rotation of a compound. If the dextrorotatory or levorotatory, these information basics about optical activity of the compound is analyzed by polarimetry. Why you need to study this polarimetry means, since some molecules will be active or effective at either dextro or levo form. If it is in dextro form, it may not give activity, but if it is in levo form, it may give activity. So that is confirmed by polarimetric analysis only. That's why you are going to learn about polarimetry. Then about thermal analysis, here you will be studying about DSC and DTA, that is the differential scanning calorimetry and differential thermal analysis. By using temperature, we are going to analyze the sample. It is also similar to, it has the similar applications of XRD, okay, X-ray diffraction. We can analyze the crystal nature, whether it is stable or not, at what temperature it is stable. So according to applying temperature, we are going to check the stability of the molecule along with its structural nature. Then about electrochemical methods and other things we'll discuss in the next class. Only spectroscopic introduction we'll see. We'll finish with the spectroscopic introduction. Remaining 2 parts we'll see in the next class. Okay. Sorry for taking your extra time from the class. Due to meeting, it has been taken more time. So in the next class, we'll be discussing about electrochemical methods and quality assurance. Hope you are clear about separation techniques and spectroscopic techniques, what type of techniques you are going to study, under which classification you are going to study. Okay. Okay, thank you all. If any doubt in this, we can ask now. If any doubts, you can ask now, or else we'll meet in the next class. Hope you all have marked the attendance. Little bit I have explained fast, I think, comparing last class. If you are not clear about any concept, we'll discuss again in the next class slowly. Okay? On Monday, 2nd hour, we'll discuss. Okay, ma. Thank you all. We'll leave the meeting now. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you for your cooperation and the response for the questions I asked in the beginning. Thank you.
Thank you.